In this video, we're going to be talking about how to complete the square when you've got more complex cases. But before I get into a specific example, I'm going to review with you the steps to complete the square when it's an easier case. Now remember, standard form of a quadratic equation looks like this. So easy cases are when this leading coefficient is 1. Or in other words, we just have, like we see in this example, just x squared. So if I'm going to complete the square, what I first want to do is move the constant to the other side, because this is the number that's preventing this trinomial from being a perfect square. So in this case, I would subtract 8 from both sides. And then next, this is now the actual complete the square, what's unique to this method. This is when this step will take place. So I'm going to take the b and divide it by 2. So that's this step. Then I'm going to square what I get when I did b over 2. And then that's the number I'm going to add to both sides of the equal sign. So in this example, 6 is my b. So in this work here, you see that I did 6 divided by 2 and got 3. And then what we're going to do is we're going to take that 3 and we're going to square it. We get 9. So that's the number that I add to both sides. Now adding it to both sides, that's an easy place to make a mistake, because we're excited when we get that number and we put it on the left side, but then forget to do it on the right. Now from here, it's quite a bit simpler. That step of finding that magic number that we add to both sides is most of the time the hardest part. But then what we're going to do is we're going to factor the left side into a perfect square and then simplify the right. So in this example, it would be x plus 3 quantity squared equals 1. Because the two numbers that multiply to 9 but add to 6 are 3, or is 3 and 3. Okay. Once we do this, then we take the square root of both sides, and when we do that, we try and remember our plus and minuses. And we simplify. So the square root cancels out the power of 2. Oh, come on. Fine. It's deciding not to work with me. Okay, there we go. And then the square root of 1 is just 1, and we've got our plus and minus there. Then we're just going to solve for x and get our two cases. So with this work, I'd have x plus 3 equals positive 1, and x plus 3 equals negative 1. Solve for x, get my two solutions. Now these solutions ended up being nice integers, but we oftentimes see fractions or ones that still have square roots, and we'll see some of that in our examples, but I just wanted to remind you what the process was for completing the square. So in these complex cases, like what we're going to see in example 1, is that we have a leading coefficient of something that's not 1. So there's a couple of different strategies or methods to do this. I'm just going to show you one particular strategy. But regardless, my first step is going to be to get the constant, in this case negative 3, on the other side. So I'm going to add 3. Now, the issue that we did not have in more simple cases was the leading coefficient. And we could just basically go through that process of taking b, dividing by 2, square it, add it to both sides. But because this number here is in front, we have to do something first before we go through that process. I really want to get rid of this 4. What I can do to get rid of it is to divide every term in the equation by 4. That cancels that out. And then I'm going to turn x over 4 into 1/4 x. Those are equivalent, because I want to know what that coefficient is. And then that's equal to 3 over 4. That fraction doesn't reduce at all. Okay, so that was step 1. Step 2 is now the completing the square process. So I'm going to take my b, which was 1/4, and I'm going to divide that by 2, or I could write it this way. Now the tricky thing with dividing with fractions is we have to remember that when we divide, it's the same thing as multiplying by the reciprocal. So dividing by 2 is the same thing as multiplying by 1/2. So it's better to write it that way because then I can multiply across the top and across the bottom. That turns into 1/8. Okay. So then what I'm going to do, so I'm not finished yet, I'm going to take this 1/8 and I'm going to square it. And that becomes 1/64. So that's what I'm going to add to both sides. So I'm going to take this equation, bring it down, and then add 1/64 to both sides. So as you can see, what I kind of have boxed here in red, it's the same equation, but now I've added this magic number. At least that's what I like to call it. It's a magic number to both sides. Now we're going to factor. Now when we get fractions, it's easy to forget what exactly is going to go with my x in here. I know it's plus because that middle symbol or that middle sign is positive or plus. Now the number that I put here is not 1/64, but 1/8. The number that I put there is the number that I got before I squared. But then on the right hand side, what I want to do is I want to turn 3/4 into a fraction that I can combine with 1/64. And I do that by multiplying. And that's going to be multiplied times, oh gosh, I'm blanking for a second. 16. There we go. Yep, times 16. Took me a second. Because 4 times 16 is 64. And then 3 times 16 is 48. Now that I have a common denominator, I can add those and get 49/64. Okay, so that's step 3, where I added that magic number to both sides. And I simplify, so all of this here, that's step 3. So then in step 4, I'm going to take the square root of both sides. And then remember that I have positive and negative. So on the left, it's x plus 1/8, because the square and square root cancel. And then when I have the square root of a fraction, I can split that up, square root of the top, square root of the bottom. And that's nice because 49 and 64 are both perfect squares. Turns into positive and negative 7/8. So I've got x plus 1/8 equals positive or negative 7/8. Step 5 is going to be to solve for x. So I have x equals negative 1/8 plus or minus 7/8. And if I split that up into my two possibilities, negative 1/8 plus 7/8 and negative 1/8 minus 7/8. Let's see what we get. Negative 1 plus 7 is 6. So this is 6/8. Or in other words, divide 6 and 8 by 2, I get 3/4. Negative 1/8 minus 7/8 is negative 8/8. Or in other words, negative 1. So x equals 3/4 and x equals negative 1. Those are my two solutions. So still pretty ugly. These fractions aren't as ugly as you can get sometimes. So this is why I'm sure those of you that are struggling with this objective, solving by completing the square with complex cases, it is maybe one of the hardest types of problems you'll do in Algebra 2. But it's just one of those things that we have to do. So let's keep doing some examples. So let's look at this one. My first step is going to get it to where I've got my constant by itself on the other side. So I'm going to add 5x, and I'm going to add 3. Adding 5x will cancel it out from the right. Adding 3 will cancel the negative 3 from the left. And I'll have 2x squared plus 5x equals 3. Then my next step is going to get rid of this leading coefficient, that's not 1, and divide everything through by 2. And I'll get x squared plus 5 over 2x equals 3 over 2. Now I'm going to do my complete the square process. So I'm going to take 5 over 2, I'll take it up here, and divide that by 2, which is the same thing as 5 over 2 times 1/2. That turns into 5 over 4. Then I'm going to take 5 over 4 and square it, which is 25 over 16. 5 squared is 25, 4 squared is 16, and that's what I'm going to add to both sides. I'll try and use colors a little bit better this time to help you see what I'm doing. Then what I'm going to do is I'm going to factor the left, and remember what goes here with the x is not 25 over 16, but 5/4, what I squared. And the right side, I want to get that to have both have the same common denominator. This one's easier than the last one. Multiply by 8. So I'm going to have 3 times 8 is 24. 24 over 16 plus 25 over 16. 24 plus 25 is 49. So 49/16. Next step, take the square root of both sides, remembering positive and negative. So I'll have x plus 5/4 equals positive and negative. Square root of 49 is 7. Square root of 16 is 4. Then to solve for x, I'm going to subtract 5/4 from both sides. So what I've got, I'm going to kind of come up here. I have subtracted 5/4, so that's negative 5/4 plus or minus 7/4. Break that up to the plus and the minus. And when I do the first one, negative 5 plus 7 is positive 2. 2/4 reduces to 1/2. Negative 5 minus 7 is negative 12. Negative 12 divided by 4 is negative 3. So x equals negative 3, and x equals 1/2. So actually, that one was maybe a little bit easier than the other, depending on your perspective. Still quite a bit of work. We filled up this section of the page quite a bit. So I know fractions are not our favorite, but we still need to work with them from time to time. Okay, let's look at an example from a little bit different perspective. So here we're going to try and find the mistake. A student worked through completing the square, or at least tried, and made a mistake, and we're going to find it, we're going to fix it. So let's try and see if we can follow the student's work. So I want to get my constant by itself on the right-hand side. So it looks like this person added 4x to both sides. So that step's good. So what I'm going to do is I'm just going to kind of draw an arrow if it's correct. So I'm not going to rewrite it. I'm just going to follow along. And then what happened from step 1 to step 2, looks like they divided each term by 3. And yep, x squared, 4 over 3x, 3 divided by 3 is 1. So we're okay there. Then it looks like they did the complete the square process. So they added 2/3 to both sides. So I want to check and make sure that that's actually the number they should have added. So if I do 4/3 divided by 2, remember that's the same thing as 4/3 times 1/2, and that's 4/6. Then I need to square that, and that's 16/36. This is the number that they should have added to both sides. Did they do that? Nope, does not look like it. So, well, actually, what I should have done here, 4/6 is the same thing as 2/3. I should have reduced that. And 2/3 squared should be 4/9, which I could have reduced 16/36 as well. So 4/9 is what they should have added. Regardless, it's not what they did. They added this 2/3 to both sides. Easy mistake to make, but it was a mistake. So let's fix it. So instead of what I have circled here as 2/3, we want them to have this. So if they made that mistake, then that seems to follow that the rest of it's going to be wrong. So let's go ahead and fix it. So now, when I factor the left-hand side, this is going to become x plus 2/3, because 2/3, this right here, that's what I squared. And 1 plus 4/9, 1 is the same thing as 9/9. 9 plus 4 is 13, so 13/9. So if I look, comparing these two steps, they made the mistake of adding 2/3 to both sides, but somehow, by a miracle, they got that right. But what they did get wrong is 1 plus 2/3, since they added the wrong number on the right, that made this number wrong. It should have been 13/9 instead of 5/3. So let's keep going. I'm going to take the square root of both sides. Don't forget plus and minus. X plus 2/3 equals square root of 13. Can't simplify that. And then square root of 9 is 3. So then I have x equals negative 2/3 plus and minus the square root of 13/3. And because I've got that square root there, I'm not going to simplify that to like we did before where we had two answers. The only thing that you could do is, since I have a common denominator here, I can write this as a single fraction. And that's how you see the answer written in most textbooks. Okay? So the mistake that they made is they added the wrong number to both sides. So this step right here, step 3, is where it broke down, and then we fixed it from there. One more example. Which of the following steps should be included in the solution of 3x squared minus 6x plus 1 equals 0 if it is solved by completing the square? So there's a couple of ways I can think about this. You can work backwards, where you look at each of these, and I could kind of, in a sense, multiply it out and see if I can match it with the original equation. That's one option. Or I can solve by completing the square and see if I can get at any point it to match up with my options. So let me show you the method that if I'm going to work from the equation, from this, and do completing the square. All right, so I'm going to start by subtracting 1 from both sides. And I'm going to divide each term by 3. Okay, so negative 6/3 simplified to negative 2. So now I'm going to do the completing the square part. Negative 2 divided by 2 is negative 1. Square negative 1. gives me positive 1, and that's what I'm going to add to both sides. So I'll get x squared minus 2x plus 1, and then negative 1/3 plus 1. I'm going to turn 1 into 3/3. Negative 1/3 plus 3/3 is positive 2/3. Okay, and then I'm going to turn this into my perfect square. X minus 1 squared equals 2/3. Okay, and I'm going to pause. Here's why. Look at what I've got, and look at the way these answers look. It looks like whoever it was stopped where I've got the parentheses, so the x minus 1 squared. Now what's different with all of these solutions is basically the number on the other side of the equals. This one doesn't have a 3 in front of it. So what I'm going to do is I'm going to see if I can manipulate this equation that I have circled in red and see if I can match it. So all except one of these options has a 3 in front of it. I can make that 3 go in front by multiplying both sides by 3. If I do, the 3 will cancel on the right-hand side. So basically, whoever this was used a little bit different method than I did. So now let's see if this matches up with anything. And lo and behold, it matches up with option B. So I solved using the method that I'm comfortable with, and then I had to do a little bit of tweaking with my equation to then match it up with the option. So I won't show you that other method that they used, because I don't want to confuse you with some multiple different ways to do it. If you're curious, I'm sure you can ask your teacher and they might be able to show you. But this is just if you solve it the way that the videos show you, that this video shows you, and you're having trouble matching your answer with an option, then hopefully this will help you do that. So for example, okay, say I completed the square and for some reason I got something like that. So if I wanted to match it with an option, I might expect them to see, or I might expect to see an option that maybe looks like this. And that's arrived at by just multiplying both sides by 5, so you don't have that denominator on the right-hand side. So you get your answer, you might just have to do one more step to match. So hopefully there's at least something in here that you can take away that might help you better answer the questions on this objective. So hope it was helpful. Good luck and keep working hard.